The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone, good evening. Am I audible? Okay. Alright, so let's start with today's session. So basically we are going to start with strings today, and we have got certain other things to wind up the C module which we should be finishing off. So today will be the last C class, and starting from tomorrow we are going to have the microcontrollers module started. So to start with, in the previous class we were discussing about the recursive function. So recursive function is nothing but a function which calls itself. So we call it as a recursive function. And apart from that, we saw how to pass an array as an argument to another function. How do we access the elements of an array inside that function? And we started with writing a recursive function, that is to find the factorial of a number. Okay. So now to begin with, we are going to start with the next topic, which is nothing but strings. So coming to the strings here, so string is nothing but an array of characters. So just like any other array, we have an array of integer, we have an array of float, we have an array of double. We also have array of characters, which is now referred as strings. The only difference between array of characters and why is it explicitly called as string is, every array of character, if it is terminated by a null character, then we are calling it as a string. Okay, so array of characters terminated by a null character. So this is a special character. This whole thing we call it as a null character. So if the array of characters has the very last one character as the null character, then we are going to call it as the string. Okay, so this will be considered as a string. So an array of characters terminated by the null character, we call it as a string. You can see here it's a continuous sequence of characters. We are going to have ASCII characters and some of its extensions stored inside the string. So end of the string is marked by a special character called as null character. And anything you are going to write it in double quotes, by default the null will be added implicitly. You don't have to explicitly add it. Now here are some of the good examples of how to declare a string. So there is a character array called char array of size 5, and it has been initialized with 5 characters. So this will just be an array of characters and it will not be called as a string as we do not have a null at the end. In the second example, we have taken a character array of size 6 and we have given 6 characters. The 6 characters are HELLO and a null. Can you people hear me? Sorry, due to rain, there was some network issue. I was trying to fix it, and I think it has been resolved. Yeah. So we'll continue. I was talking about the initialization of the string. So if you look at this, we have multiple ways of initializing the string. In the first case, it will not be a string, it will be a simple character array of size 5. Okay, so this character array is going to have 5 characters inside it, but as there is no null at the end, we don't call it as a string, it will be a simple array of characters. Then if you take str of size 6, now this time we call it as a string because we have a null at the end. So this str will get 6 bytes of memory allocated and I have got 6 characters inside it. At the end there is a null, so we are going to call it as a string. So here one more way, as we are initializing, we are not specifying the size. Based on number of initializations we have made, the size is automatically decided. So this is not valid way of declaring a string. Okay, and this one is considered because when you are providing multiple strings without a comma, string concatenation happens. So this whole thing will be seen as one string and it will be stored inside str. In all of these cases, so you are going to have an array called str taken. Let me say like this. So this is an array called str which is of size 6. Okay. So this str will get 6 bytes of memory allocated and it is filled with 6 characters. So the 6 characters in all of these cases is H, E, L, L, O and one null character. So because you see a null at the end, we are going to consider it as a string. So like this, we will have HELLO in all of the cases. So we'll have HELLO terminated by a null at the end. So this is one character. \0 is one character. We call it as a null character. So that way your string gets the memory allocated and it will be stored inside the memory block. So in the last case, because it is not an array, it is a pointer. So somewhere in the memory, hello gets the memory allocated. So just like this, somewhere in the memory, hello gets the memory allocated. Let's say the address is some 500. So that address should be held inside one pointer variable. So this is my pointer variable called str. So str will hold the address 500 and pointer will be pointing to that memory location. So that is how the string gets the memory allocated. So string is nothing but array of characters which will be terminated by a null character. Okay, so that is how the strings can be declared. Now, associated to these strings, you can look at the size of these strings. So in the first case, it's a simple character array of size 5. So size of character array 1 gives you 5 as there is 5 bytes of memory allocated. Then size of character array 2. Character array 2 is an array. It has been initialized with 6 characters. Anything specified in double quotes will have a null added implicitly at the end. So 6 bytes of memory allocated. Size of character array 2 will be 6. Okay. Then here there is a character pointer called str, hello. So we are looking for size of str. Str is a pointer variable which is why we get 4 or 8 bytes depending on the bitness of the system. 4 in case of a 32-bit system, whereas 8 in case of a 64-bit system. Okay, so like this the memory gets allocated. Now can anybody answer what will be the output of this program? Will you get a wow printed or will it be a her printed? Okay, now if you look at this, so first we have size of hello world. So hello is one string, world is another string. So as it is not separated by a comma, so it gets combined together and it will be seen by your compiler as hello world. So there is hello world. So they both are combined together and at the end you will have one null character. Okay. Then on the other side, size of hello, there are 6 characters. So it gives you 6. Size of world also has 6 characters. So there is 6. Size of hello world with a null character is nothing but 11. So 11 equal to 12 is condition false, which is why her gets printed. Okay. So here two strings gets concatenated. They gets combined together. So while it is being combined, it adds from the null of the previous string. Okay. So actually how it is? On one side I have hello with a null character. Okay. And the other word is world with a null character. So now how is this combined is? The world with a null character gets returned from the place of null here. So like this, world gets returned. Okay. So here world gets added with a null character. So I totally will have 11 characters, which is why size of the first case will be 11. Size of the other two cases is 6 plus 6, which becomes 12. So that is how you get a her printed as the output. Now there are some built-in functions which are used to find the length of the string. I'll show with some examples here. So I'm going to open my VS Code. So now whenever we want to perform certain operations, we have got something called as string related functions. And whenever you want to make use of these string related functions, then we are going to include a header called string.h. Okay, any string related functions you want to use, then you should include a special header file, that is string.h. Okay, this is string.h. Now, the very first function we have got to study is strlen function. I take a character array called str. I will initialize it with a string called hello. Okay. Now please remember the difference between size of and strlen. So size of will tell how many bytes of memory is allocated, whereas strlen will tell how much is the length of the string excluding the null character. Okay. So it is going to provide the length of the string excluding null character. So I'm adding strings.c file. All string related functions I'll demonstrate here only. First I have to include the header file, as usual stdio.h. One more header file, that is strings.h. String.h. Okay. Then in the main function, I'm going to take a character array called str, which will be initialized with a string called hello. Okay. I'm adding one printf to show you what will be the output of size of str, and one more is string length of str. String length is a function, size of is an operator. Okay. Now strlen is a function which finds the length of the string excluding the null character. Okay, so it is to find the length of the string excluding the null character. So now I am compiling this. Okay, cd internship gcc string.h strings. Okay, so there is one warning which is okay. So I'll use %ld to avoid the warning because size strlen gives me a long integer. Okay, size of actually should use %lu. Anyways, both of them I'll ignore. So I'll just continue to execute even after the warnings. You can see size of str gives me 6 because it is giving me the length including null character. There is HELLO and null. Anything written in double quotes will have a null added implicitly. So size of str gives me total memory allocated for str. Whereas string length of str will tell how much is the length of the string excluding the null character. So excluding null, I have only 5 characters here. So strlen is giving me 5, whereas size of is giving me 6. Okay, so that is the very first one, strings.h, where we are using strlen function. So strlen is a function which takes the character as array of characters as its input, gives me the length of the string excluding the null character. Then we have this strcmp function. Now what strcmp function does is, it compares two strings for which I should have two strings. So I'm taking string 1 with hello, another character array called string 2 with world. Okay. Now how to do this is, we are going to compare. To compare, I'm going to make use of strcmp function. It takes two strings as its input, whatever is in string 1 and whatever is inside string 2. It returns one integer which I am going to collect it into an integer variable. Okay. Now what integer it returns is based on the two strings. If the two strings are equal, then the value RET receives is 0. So I am going to say here, if RET is equal to 0, then I'm going to add a printf saying strings are equal. Okay, strings are equal. Whereas when I'm going to make have RET received with a non-zero value, if RET is a positive value, okay, greater than 0, it says string 1 is greater than string 2. Okay, else if RET is greater than 0, then string 1 is greater than string 2. So string 1 is greater than string 2. Okay, so that is when RET value is greater than 0. Otherwise, obviously RET value is less than 0. So then I am going to say string 1 is lesser than string 2. Okay, so like this we have got the program written. Just observe, I have got two strings. It is not going to compare with respect to the length. It compares character by character. H and W is compared. It is not matching. And H comes first, W comes at the end. The difference between H and W will be returned. Okay, it will be some negative value. So based on that, I am going to say string 1 is less than string 2. So it is going to compare the characters of the string. Okay, so you can see string 1 is less than string 2. I will interchange. I will make this word and this one as hello. Okay, now W minus H will be a positive value. Okay, as it is positive value here, I'm going to have string 1 greater than string 2. Now when both of them are equal, it returns a value 0. Okay. If both of them are equal, the value returned will be 0. So you can see strings are equal. Okay. So that is how strcmp function works. It is to compare two strings. So after comparing, it either returns the value 0 or non-zero value. Based on the return value, you can make the decision. Not just the first character. It compares character by character. Whenever it is a mismatch, it returns. For example, let's say I write HELLA. Okay, so here I have HELLO. Now what it does, H and H will be compared, it matched. So it goes and compares E and E. Then it compares L and L. Then it compares L and L. Until then it was fine. When it compared A and O, it is a mismatch. Now A comes first, O comes last. The difference between A and O will be some negative value. So string 1 is less than string 2. Okay, whenever it identifies a difference, it returns. So until it reaches null character, it keeps comparing. That is your strcmp function. Then we have is strcpy. Strcpy is to copy contents of one string to another. For that, I'll go with another example. So, okay, Nitya is saying, give one string in small and the other string in capital and check. Okay. Now see, that will also be mismatch only. So capital H comes first, small h comes last. Okay, it is capital A to Z, then small a to Z. Okay. So the first thing it does is a mismatch now. H and H it is compared. They are not of same size. They are not matching. So now smaller h minus capital H gives you one positive value. So RET greater than 0 will be true. String 1 is greater than string 2 will be returned. Okay, string 1 is greater than string 2. So that when lengths are not same also the same happens. Let's say HELLO. Here I have only hell. Now what happens? H and H is compared matched. E and E is compared matched. L and L is compared matched. L and L is compared match. Now I have a null here. Null and O are not matching. Null comes first, O comes at the end. So null minus O is a negative value. So it says string 1 is less than string 2. Okay. So like this it compares. Yes, it compares the ASCII equivalent, and if the ASCII is not matching, then it is going to return the difference between the two ASCII characters. So that is strcmp. Next we have is strcpy function, which is used to copy. So string 1 as hello. I want the contents of string 1 to be copied to string 2. Okay. String 2 is empty. I have string 2 allocated with 10 bytes. But string 2 is empty. Okay. I want the contents of string 1 to be copied to string 2. That is when I call strcpy function. First one should be the destination. Second one should be the source. Okay. First one should be the destination. Second one should be the source. The contents of source will be copied to the destination. Now after this, if we print the str2 value, then we are going to have the contents of string 1 copied to string 2. Okay. So like this, if we print str2, we are going to have hello only printed. Okay, so I'm going to compile this and I'm executing. So I can see string 2 has a hello now. So this is strcpy function which is used to copy two strings. Okay. The next one we have is strstr. Str and strchr, you don't have to actually worry about it. So str is to search for a small string in a big string. So when you have to search for a small string in a big string, then you are going to make use of str function. Similarly, when you want to search for a character inside a string, then you are going to make use of strchr function. Okay. To search for a string inside a big string, we use strstr. To search for a character inside a string, we make use of strchr. So both of them are not necessary for you to be known, but still, if you want to know, I'll just give an example. So this is my string 1. Let's say I have a character called ch, which is having h stored. Or let's say I have a e stored. I want to search for e inside str1. So that is when I will make use of strchr function, to which I pass the string and the character to be searched. If the character is found, strchr returns the address where that character is found. My character is found here. That character's address will be returned, which you are supposed to collect it into a character pointer. Okay, so CPTR is going to receive this, and percentage yes equivalent of CPTR is going to have ELLO printed. If it is found, only then it returns the address. So you can see this is where E is found, that address was returned. Percentage yes equivalent is giving me ELLO printed. If it is not found, let's say I'm searching for Z, not found. If it is not found, then it returns null. Percentage yes equivalent should give you segmentation fault. Okay. When character is not found, strchr function is going to return null. Okay. So that is when, if you see CPTR, if you print the string from CPTR, you get segmentation fault. So that is about your strchr function. One last is string concatenate. I have string 1 with hello. I take string 2 with world. Okay. I want the contents of string 2 to be added along with string 1. So please make sure you have enough size provided to have the concatenation done. So when I call strcat function, I'm going to pass string 1 comma string 2. Whatever is inside string 2 will be added along with the contents of string 1. So that is strcat function. Now if I print string 1, I will have hello world. Okay, so I'm printing string 1 I will have a hello world printed. Okay, so here I'm going to compile and execute. There is a hello world printed. Okay, so that is string concatenate. You want to concatenate or combine two strings. So the contents of string 2 is been added along with string 1. So that is string concatenating function. So these are the built-in functions which you can utilize anytime to perform the operations on strings. Okay. So strchr will search for a character in a string. Str will search for a string in a string. Okay. So don't worry much about str and strchr. Otherwise, very commonly used is strlen, strcmp, strcpy, strcat. 4 functions, if you know, it has to be enough. So this is about strings as in how to perform the operation. Okay. So adding of two strings is nothing but concatenating the string, which is done using strcat function. Okay. So no, str1 plus str2 is not correct. You cannot do. You want to add two strings, it has to be using strcat function only. Okay. Now coming to the next topic, we have a storage classes. It is a simple topic. Okay. Generally what happens is whenever you have a memory provided, so in any operating system you will get certain bytes of memory. Okay. Now in any system the whole memory is divided into two sections, especially in the Linux based operating systems. Okay, but it happens in your Windows also, do not worry. Any memory which is available in your computer, it is, I'm speaking about the RAM memory. Okay, random access memory. So the memory gets splitted into two sections. One is the user space, the other one is the kernel space. So user space is where we being the programmers can access the memory. Kernel space is where your operating system is accessing the memory. Okay, we have two spaces, user space and kernel space. User space is where we normal users will get the memory allocated. Kernel space is where operating system is getting its memory allocated. We being the normal users cannot access the kernel space. It is a restricted memory. Okay, anytime you try accessing the kernel space, you get segmentation fault. Now, this memory will have n number of processes running. If you look at my system, I have many processes running right now. I have a Microsoft Edge running. I have a journal running. I have VS Code running. I have GoToMeeting running. I also have a Chrome running. So I have n number of processes running at a time. Now these processes are considered as P1, P2, P3, P4 and so on. Each of these processes will get certain bytes of memory allocated. Okay, all of these processes will get certain bytes of memory allocated. One of that process is your program. Okay, your C program is one of the process which is running. So here what happens is, when your process gets certain bytes of memory allocated, that memory is divided into 4 segments. One is the text segment, then we have stack segment, we have data segment and the heap segment. So at the bottom you see is the text segment, above that you see is the data segment, then we have the heap segment, we have the stack segment. Okay, so let's say your process is your VS Code. Or let's say your process is your online compiler. Once your process is running, you get certain bytes of memory allocated. And that memory is split into 4 segments: text segment, stack segment, data segment, heap segment. Now, who sits in each of these segments is a question. In the text segment, your program is placed. Whatever program you are going to write is placed in the text segment, and that should not be modified. Hence, text segment is also called as read-only segment. Okay. So text segment is only called as read-only segment. You cannot modify your program once it is written. Okay. While the program is being executed, you cannot modify your program. Hence, your program is written in a separate memory called as text segment. Then above that you have is data segment. Data segment is further divided into 2 sections: initialized and uninitialized data segment. I hope you remember yesterday we studied about static. Any variable, along with the variable we declare static whenever you want to return a variable from one function to another. That static variable sits in the data segment. So it sits in initialized data segment if it is given with a value. It sits in uninitialized data segment if it is not initialized. Okay, so that is your data segment. Above that we have is heap segment where dynamic memory allocation happens. You don't have to worry about dynamic memory allocation. It is like the memory which will be handled by the user. Okay, we being the user, if we want to handle the memory, then it is in the heap segment. And one last is stack segment where all of your variables are placed. Okay, your variables are placed in the stack segment. Now, here are some of the things. Okay, let me explain you about a auto local variable. Okay, I'm explaining about auto local variable. For example, inside the main function, I declare one variable, okay, int num. This is an example of auto local variable. The num can be accessed only inside the main function. It is local to that main function. We call it as auto local variable. Now, we have a register local variable. Any variable declared with register keyword, we call it as register local variable. Why do we have to declare it as register is when you want to access this variable more often. So whenever you have to access the variable more often, then we make it as register. The reason behind that is memory for a register variable will be present close to the CPU. Okay, memory for any register local variable will be given close to the CPU. So because it is close to the CPU can access it easily and with less amount of time. So whenever a variable is to be accessed more often, it is made as register. Okay. Then we have a static local variable. So static local variable is when you want that variable to stay even after you step out of the function. Okay. So you want to make that variable stay even after stepping out of the function. You're going to take it as static. Okay. Let me specify here register when variable is accessed more often. Okay. So when you want to access this variable more often, it is register. Similarly, in case of static, it is when you want the variable to stay even after stepping out of the function. Okay, when variable is to be with user even after coming out of the function. So even after coming out of the function, you want that variable to stay with the user, then you have to make it as static local. Now coming to global variable. So global variable means it's a variable which is declared outside a function. Okay. So let's say I have the main function here. So I have the main function here, and outside the main function, I'm going to have one variable declared. This is global variable. The reason why we take a global variable is we have to use this anywhere throughout the program. Okay, to use the num anywhere in the program. Okay, you want to use it anywhere in the program, then it is a global variable. In fact, you can use it in other files also. Even in other files. You want to use it in other files also, then you can go for a global variable. Now, static global variable means it's a variable you want to use anywhere but not in other files. Okay, you write static here. Okay, to use the num anywhere in the program, even anywhere in the program but in the same file. So you want to use that variable only in that file, then you have to make use of static. Okay, so these are the variables. So in case of global variable, you are going to use that variable anywhere. Inside main function you want, you can use. You write another function, you can use it in that function also. So that is global variable. You take another file, you want to use it in another file also, global variable can be used. But static global variable should be used only inside that file. You cannot use it in other file. Okay, using it in other file is not possible. So that is global variable. So that is what we have here in the example. Okay. So, and when you want to use a global variable from one file to another, we make use of extern keyword. This is a global variable. I want to use it in another file. So I should make use of extern keyword. Okay. Let's say I'll write it here. This is one global variable file. This is another file. Let's say you want to develop a project. You don't do it in one file. You are going to do it in multiple files. So this is our 1.c file and this is our 2.c file. Okay. Now I write my main function here. One global variable I'll have and I'll write my main function here. The other function, let's say I write it in another file. So let's say I'm writing a display function here in a separate file. I don't want to write everything in the same file. If this variable should be brought to this file, then it is brought with the help of extern keyword. This global variable to be brought to this file. You want to use this num not only in this file, in the other file also. It is brought using extern in num like this. Okay, that is global variable. Now, if it is static global variable, then using it in another file gives you error. Okay, so let's say this is static. Okay, if you write it like this, then here using extern is not possible. You cannot. It has to be used only in this file. Taking it to the other file is impossible. Okay, so taking it to the other file is not possible like this. So you cannot use this in another file. Okay, so that is how global variables are taken. There is a global variable you want to access in another file, then you do it with the help of extern keyword. There is a static global variable you want to use it in another file, not possible. So that is going to give me an error. Bhavya, I'm saying static and global are two different things. Global is one thing, static global is another thing. Okay, so in static you have static global, you have static local also. If it is static local, you put it inside a function. If it is static global, you put it outside the function. Okay, so these are the types of variables you can declare. So please note this down and we'll take a break of 2 minutes. We'll start with last chapter. Okay, so this is about the storage classes. So the next we have got is to start with preprocessor. Okay, next chapter is preprocessor. So whatever we have been writing as include so far, that is a part of preprocessor. Okay, so ash include stdio.h, ash include string.h. So they all are preprocessor directives. Okay, ash include will say please include this stdio.h file. Okay, that we call it as ash include. Now it is a kind of including the header file. Okay, ash include is to include a header file, and we have two reasons to include a header file. So one reason to include a built-in header file is to make use of your hardwares. For example, you want to print something, you want to read something, you want your keyboard, you want your monitor, that is asked by including the built-in header file stdio.h. So for that reason we use built-in header file. Then we write our own header file. When we want to write the functions prototype and I want to share it among other people, then that is to include a user defined header file. So the difference between a header file and a source file is your .c file is where your programs are written. So it will have the functions you are going to write. It will have some variables you declare. It will have some macros you write which cannot be shared. Whereas anything you put inside the header file can be shared. So what will you have inside a header file is you will have functions prototype. So this whatever we wrote yesterday, this first line is called as functions prototype. Okay. So anytime you wrote the functions prototype, that is written, this is functions prototype. So that is written inside your header file, which can be shared among other files also. Okay, so that is header file. It will have some macros. It will have some data types which can be shared among the people. Now, two ways of including a header file. I think we have always been using this. This is to include a user-defined header file. Sorry, built-in header file. So stdio.h, string.h, they all are the header files returned by the system, by the compiler. They are built-in header files. You did not write it. So to include such header files, you use angular parenthesis. This we call it as angular parenthesis. So whenever you include a header file like this, it searches for the header file in your system main path. So there is one dedicated path where built-in header files are stored. Whenever you include a header file using angular parenthesis, your computer will search for that header file in the standard path. If a header file is included using double quotes, then that is to include a user-defined header file. Okay, so we being the users should include a user-defined header file. So to include a user-defined header file, we use double quotes. Now, why do we have to use double quotes? I want that header file to be searched in that specific path. Okay, I don't want that to be searched somewhere. I want it to be searched only in the place where I have stored it. So to include a user-defined header file, if I create my own header file, then it should be included using double quotes. Okay, and any header file should be included for only once. Okay, hereafter, whenever you create your own header file, okay, I will teach you how to create a header file. So in the header file, you will have some functions prototype written. This is my header file. Let's say head.h. Okay. Now what will you write inside this is you will write all functions prototype. Let's say you are writing a sum function. Sum functions prototype, you will write it here. Okay. Let's say you write a display function. That display functions prototype, you are going to write it here in star ptr, something like this. Any function you write, its prototype is written here. Now when you are writing a header file, please have a habit of writing it like this. First line, ash if not defined of name, ash define name, and at the end ash endif. So why do you have to write it like this is, whatever you write in the header file should be written in your program for only once. By mistake, if you include a header file for twice, it should not cause you any error. That is common. Okay. Especially when you are doing big projects, including a same header file for more than once is common. Okay. Even by mistake you include a header file for more than once, you have to make sure that your computer is including it for only once. Okay. You cannot let it get included for more than once. You have to make sure that it is being included for only once. And that is done with the help of this ash if not def, ash define, ash endif. So when you write these lines before the contents of your header file, then you will make sure when you include this head.h in your files using double quotes, even if you include it for more than once, the contents will be included for only once. So that is head.h. That is how you are going to write your own header files hereafter. Now what is this ash define is? We call it as macro. Ash define is a macro. Ash define, let's say pi 3.142. So ash define is a way of defining a constant. Giving a name for a giving a name for a constant, we call it as a macro. Okay, it is done using ash define. So object like macro is a simple identifier which will be replaced by a code fragment. See, ash define buffer size 1024. So wherever 1020 buffer size is seen in your program, it will be replaced by 1024. Okay. So ash define is the process of defining a macro. You give a name, give a value for it to represent. So for example, ash define buffer size 1024. Wherever buffer size is seen, it will be replaced with 1024. Similarly, wherever pi is seen, it will be replaced with 3.142. So that is macro. Okay. So macro is giving a name for a symbolic constant. If endif stands for if not defined, endif is to end the if condition. This is to make sure that the contents of header file is been added for only once in your program, even after you include it for multiple times. Okay. So that is your macro. So we have one more macro here. Okay. This is one more macro. We call it as function like macro. Ash define set bits num comma position. I'm writing a macro called set bit. The macro is going to take two inputs, num, position. So after taking two inputs, what should it perform is specified here. I want it to perform num or with one left shifted for position times. So actually wherever this macro is found, it gets replaced with the value it is representing. Means once this macro is returned, it is replaced with num is receiving 0, position is receiving 2. So this line will be replaced with 0 or with 1 left shifted for 2 times. Like this it will be replaced. Okay. So this kind of replacement happens when a macro is called. So macro means it is a text substitution. You write a constant or you write a value it is going to represent. Okay. So that is a macro. And this is a multi-line macro. When you want to write a macro using multiple lines, you are going to add a backslash at the end of each line. Please remember there should be nothing available at the end after this. So if you are not comfortable writing a macro in a single line, you can split it in multiple lines. In order to split it in multiple lines, every line should be terminated with a backslash. Okay, so that is about the macro. And these are some of the built-in macros. You see, double underscore file double underscore is a built-in macro. It will be replaced with the file name you are working. Double underscore date double underscore is a macro. It will be replaced with today's date. Double underscore time double underscore is a macro. It gets replaced with today's time. Double underscore func double underscore is a macro. It gets replaced with the function you are working. And double underscore line double underscore gets replaced with the line number in which you are working. Okay. Harish is asking, without writing macro, we can use the functions. Yes, you can. You want to write macros, you can write. You want to write functions, you can write. Okay. These are some of the built-in macros. File, date, time, func, and line are the 5 built-in macros. So this completes the C module, and we now have to start with microcontrollers module. So but the microcontrollers module will be starting from tomorrow. Okay, starting from tomorrow you are going to have the microcontrollers module started, wherein you will study how to implement a simple embedded system. You will study about some of the peripherals. You will be given with a project. That project will be done with the help of the C programming language. Okay, using the C programming language, the things will be done for programming. You will study about some of the peripherals, how to configure some of the peripherals and how to do the project. Okay, so this PPT is already there in your LMS, and this notes what you see will also be provided to you, which you can access anytime. Okay, so it will be there in your LMS only, you can access it anytime. So that is about the contents. Macro, I'm just briefing out. Whenever you write a macro, you write it using #define. So you want a name to be given for a constant value, you do it using #define. You give a name and this is the constant value it has to represent. Similarly, you give a name for the operation you want to perform. That is also done using #define. The name you are giving is setBit and it has to take 2 inputs, num, position. So whenever this setBit macro is used, it gets replaced with the value it is representing. Okay, so that will be your macros. You can start working on assignments. You can keep it ready. From tomorrow, you will start with your microcontrollers module. The project will be started. And this is your LMS. So in your LMS, Under internship, you're going to find all of your class recordings. Okay, so here under the class recordings, you can see all of them. Today's class I will be adding here after the class gets completed. Also, I will add this document which you can refer anytime. Okay, so that is it. You want to study anything in brief, I mean in detail? C is not something which can be learnt in 10 or 15 days. In fact, we take it for 3 months. The C module will be taught for 3 months in our course. So, you are interested, you can join. Okay, wherein you will study the C module in detail. So, it will be for a duration of 3 months. Just C will take 3 months. Okay, so that is something you will have to figure out. Anyway, starting from tomorrow, microcontrollers module will be started. Thank you all. It was great teaching you all with respect to the C module. You can leave the session now, and your next session starts from tomorrow with respect to the microcontrollers module. Thank you all and have a good time.